All right, we are live, and we are going to wait just a minute or so to have our attendees join us, since the software seems to kind of allow folks to come in slower than sometimes I hit live. But I'm going to, I see people are joining us now, which is great. I appreciate all that. Get this all set up so we can have people also today. We're going to be able to put questions in our chat function, as well as there's a Q&A section, so either or be fine for everyone to join us. So that's good. And today's recording, today we're for our webinar. We're going to be recording this to anyone just jumping on. So so if you find this to be valuable, we hope you can share this. We'll send a link out later. That's appreciative. And for anyone who's wondering, my name is Ben Reeder. I'm with the RG Group, and today I'm helping moderate today's webinar for our online or our AMR safety webinar. But I'm really proud to introduce our actually speaker today. We have Mike Kunkel with us, and Mike's a partner with the RG Group and has been doing a lot of work with us. And Mike is the president and principal consultant of the MEK Consulting, which specializes in robot safety training and robot risk assessment. You know, Mike's got more than 30 years experience in manufacturing, which includes, also 15 of those years as manufacturing engineer at Harley-Davidson. So when Mike was with Harley, he actually was a corporate robot safety resource and wrote the safety standard policies with them and taught robot safety and the facilities and reviewed and approved all the robot assessments and every installation purchased by the Harley-Davidson York. But he's also the chairman of the RIA Standards Committee and member of the ANSI RIA R15.06 Standards. And today we're going to be talking about the .06 and .08 and what's coming. And so I'd just like to hand this off to Mike, because obviously he can kind of set us straight if everything's going on and what's coming in the future. So Mike, the floor is yours.
All right. Good morning, everyone. I hope we don't bore you too much today, but what we're going to talk about today is the ANSI RIA R15.08 Part 1 2020, which is the safety requirements for mobile industrial robots. And you can see the standard there before you. If you're getting into this field of endeavor, whether you be an integrator or an end user, I would suggest that you purchase this standard either from ANSI, or you can get it directly from RIA, which is now called A3. Uh-oh, something's not switching here, Ben, so I'm going to have to flip things around here a little bit.
Gotcha. Of course, technology's always fighting.
There we go.
Hey, there we go. I see it.
You want to click your continue button there. It says meeting being recorded.
Yep, we're being recorded, so you're good.
Okay. This standard was authored by actually 162 active subcommittee members, which consisted of equal parts of AMR manufacturers, integrators, and IMR manufacturers, integrators, suppliers, and end users. And they were from all over Europe, Canada, Mexico, even Asia, and the United States. So we had quite a bit of representation here. Part 1 really speaks to the IMR manufacturers' safety requirements, what they have to do to provide you, the end user or the integrator, with a relatively safe product. Part 2 of this standard is currently being written by the subcommittee, and it will speak to the safety requirements for integrators. The writing of Part 3 will be undertaken immediately after the R1508 Part 2 is completed, and that will speak directly to you, the end users, who may be included today. The R1508-1 2020 table contents actually follows what those of you who use the R1506 robotic safety standard are familiar with. You have the forward and introduction, the forward, then the introduction, then part one, which are the requirements for industrial mobile robots. You'll have clause one, which is the scope. And I have not gone into detail. There's many parts to each one of these clauses that you should read for yourself. We just don't have time to cover it all right now. Two is normative references. Three is terms of condition. Four is hazard identification, one of the most important ones in there. Hazard identification and risk assessment. What do you need to do your risk assessment? Five is design requirements and risk reduction measures. Six is verification and validation of the risk assessment. And seven is information for use and markings. Uh, Annex A then is a list of significant hazards that can be present. And then Annex B describes the different types of IMRs. And you're wondering now what an IMR is. We'll explain that to you a little later. You're used to calling them AMRs, but industrial mobile robot is an IMR, and it takes many different phases other than just what you think of as an autonomous mobile robot. Okay, Annex C is parameters and thresholds for determining performance levels. Annex uh, Annex D is verification and validation of safety. Annex E is illustrations. Annex F is one of the most important annexes in here, and it could apply to you as well as the manufacturer, the integrator, or the end user, and that's stability testing. We'll talk about this a little more. You need to test the stability of your product to make sure that it's stable as it travels through the factory. Yeah, we lost something here again. There it goes.
There we go. We got it.
Okay, we flip back. You probably noticed, as I said before, we're talking about IMRs instead of AMRs. Here is the reason. As we developed the U.S. national standard, the subcommittee really realized that there's many types of industrial robot available or industrial robot fleets, IMRFs. IMRs incorporate many mobile platforms that can either be automatic guided vehicles, AGVs, or autonomous mobile robots, AMRs. This is why we call this an IMR, industrial mobile robot. It's important to note that if they are an AMR or an AGV and they contain, or an AMR and they contain forks like a lift truck, they do not comply with this standard. They fall under the ANSI B56.5 industrial standard. What is, I'm going to, instead of reading all this to you, I'm going to try to give you the short and sweet of it. An IMR type A would be a standard AMR that you're familiar with, such as the MIR 100 or 200, something like that. IM Robotics Bolt, something of that sort without any attachments on. and they can be integrated into a type B or C. And if they add attachments other than manipulators, then they become an IMR type B. If they have an attachment, you can still pick up something and transport it around the factory, have somebody load a box on it with something on, transport it to somewhere else. It's still a type uh, A IMR. If you put an attachment on a type A, it becomes a type B. And if you add a manipulator to it, it becomes a type C. If they're changed from autonomous to guided, the IMR type A becomes an AGV, to which this document does not apply. See ANSI ITSDF 56.5, which is your autonomous forklift standard. So enough of this. You can read all this. It's in the standard. I'll just give you some ideas. Here are some examples of a type A. The one, of course, is the mirror. The second is the IM Robotics Bolt, which newly came on the marketplace. And then we have the other type that you see down there, which is actually a Mirror 200, picking up a shelf of material and moving it. It's still a type A because that rack is not attached to it. You just have to pay attention to the stability clauses of Annex F of this document. Okay, type B are active attachments that include roller tables, conveyors, linear lift devices, or picking attachments. They can be passive or active, and sensors can be added to a type B without changing the type B classification. If a manipulator is picked up or moved by the platform with the sole intention of moving it and depositing the manipulator, it still remains a type B IMR. If the attachment is not part of the platform, it's still a type B. But a type B will become a type C if all active attachments are removed, but passive attachments remain. The type B is still a type B. So we'll go into that a little more. If navigation capabilities and the scope of navigation and application will switch between different types of navigation, the mobile platform will be classified according to the navigation system that will provide the highest degree of autonomy. Example, if the navigation capabilities of the platform with non-manipulator attachments enable autonomous as well as guided uh, applications, it is classified as a type B and covered in the document. These are some examples of a type B uh, IMR. The one is simply a mirror with a tow hook on. It now became a type B because it has an active tow hook on it. The other one is a mirror 200 to which a roller conveyor and cage has been attached to the top and the programming in that mirror actually controls that roller conveyor. So that's actually a type B. The type C IMR is constructed from an AMR or an AGV with a manipulator as attachment. Notice we're saying manipulator, not industrial mobile robot. Any kind of manipulator with multi-axis manipulator is considered a manipulator in this standard. If it's a if the AGV with a manual integrating a different manipulators does not change the IMR classification. The mobile platform is an AGV, removing all manipulators from the platform reverts it to an IMRC, to an AGV classification again, and this does not apply. The ANSI B11 or 56.5 applies. If the mobile platform is an IMR, removing all manipulators from that platform reverts the IMR type C back to a B. You can read all this. This is a chart. We're going to skip all the verbiage here. This is a chart that's in the R15.08. It's table 1.1, and it really explains whether your IMR would be a type A, a type B, or a type C. Pretty easy to determine using the chart. Here are some examples of type C IMRs. The first is a mirror with a universal arm mounted upon it, and it's intended that the mirror and the whole programming will work together to perform one unit. So that's a type C. The other is an AGV type. It falls under this standard as a type C. It does not have forks. It's autonomous. It's guided, not guided, and it has a robot mounted upon it. So it's a type C. The 1508-2020 is for manufacturers, but how might it affect you integrators and end users? Well, the IMR manufacturer, first of all, must conduct a risk assessment for each model IMR they produce to make sure that they meet the safety requirements of this standard. And I can really assure you that when part 2 and part 3, part 2 for the integrator and part 3 for the end user are completed, both are going to require the same as in the R1506 2012 that you complete a robot or a risk assessment. You can do this using RIA's TR R15.306 2016 risk assessment methodology as they utilize the functioning safety requirements, and they're both the same in the 1508 and the 15, excuse me, there's a mistake, 1506. If you purchase a type I or type A IMR and have nothing attached to it, you still need to conduct a risk assessment to ensure the safety of your personnel. But if you're moving that tall rack, such as the one that we gave in the example, then you should actually conduct that risk assessment and stability testing uh, listed in Annex F of Part 1 of the 2020. If you purchase a type AMR and attach a basket, conveyor, etc. to the top of it, it now becomes a type B. So if you're an integrator and you're putting that on for a customer, it now you would be, or if you're an end user and do it, you may now be considered the AMR integrator, and you should conduct a risk assessment and again make sure you comply with the stability testing listed in and you list the results of the testing in your risk assessment. If you purchase a type A and you attach a manipulator to the top of it, it now has become a type C. So you could be the integrator and you may be considered the actually, or an end user, you might be considered the IMR manufacturer. And you should conduct a risk assessment, making sure that it complies to all the requirements of this document, especially the stability testing in this document, as well as list the uh, parameters for the risk assessment and do your list these in the risk assessment. It's important to remember that safety scanners used like SICK and all the others that we use in to detect obstacles from the sides of IMRs meet the functional safety requirements of protection level D, category 3, which you're all familiar with probably as a form of protection that you need to meet. However, what you should be aware of is that the front and rear 3D cameras currently used on almost all AMRs are not safety rated. Thus, they do not meet the requirements of protection level D, category 3. It's not anything that anybody is uh, immune to. All the robot manufacturers now are aware of it, and they wrestled with this. And what we have come up with as a means to satisfy that safety is that you must conduct uh, stopping distance tests to make sure that a robot will safely stop before it hits someone. And the way you do this, first of all, you want to do a fixed obstacle, and then when the robot stops, repeatedly measure that distance maybe a dozen times to make sure it's repeatable. Record that distance. Now you also, once you know what that distance is, have someone walk towards that IMR at a walk speed of about 1600 millimeters a second. That's about 5 feet a second, a normal walk pace. And as soon as it stops, measure from the tip of the closest toe to that IMR, repeating that again, and then record those results in your risk assessment. That's about it, guys. That's about all we have time for today. We can open this for questions if you have any questions.
Yeah, so the chat box available. Plus, I'm actually allowing everybody on this call to talk if they'd like. So if they want to use that as well, you can certainly chime in to this. But we have the messaging if you have any questions. So one of the questions I have, Mike, is so part 1 is currently rolled out, correct? So these.
Yeah, that was rolled out actually in December of 2020, right before the start of the 2021 year.
Okay, so these need to be considered now. Part 2, is there a time frame?
We're striving to get it completed by the end of this year, but again, with 162 members, everybody has to vote to approve it. So that, and then after they approve it, then it has to go to an open questioning period or commenting period, and all comments have to be answered.
Okay.
So that can take a while. And then once all those comments are complete, it goes to what is called the Standards Approval Committee, the SAC, which again, I think there's about 30 members of that. And if they have any questions, they must be answered. They are actually unanimous. Uh, they must all agree.
Okay.
Uh,
Yeah.
the standards committee is a majority vote. When it goes to the standards approval committee, it's a mandatory that all of them have to agree. Once they agree, then it can be passed on to ANSI for a publication.
Okay. Hey, I got our first question here is, would the risk assessment be conducted by the manufacturer or should it be done by the independent third party? And is there a certification as well?
It should be done by all three. It should be done by the robot manufacturer. He only needs to give you the results of that risk assessment. He does not need to give you the risk assessment, which he generally does in his tables for use. He'll tell you stopping distances, stopping times, all that stuff. That's the results of his risk assessment. The integrator and the end user will both have to do a risk assessment as they do with the R15.06. A lot of people don't, but the standard calls for it. So they should both do it. You could do one, and if you wish, have a third party come in and do one on top of it, not seeing what you did to see if it passes. We do a lot of third party risk assessments. Matter of fact, I'm doing one now for an integrator, another integrator here in New York, who I've done them for many times before. Their customer asked for an independent third party.
Okay. Is there a certification as well that comes with that?
There is not. However, I have two guys on my staff who are certified machine safety experts by TUV.
Okay.
So they are certified. And if somebody, well, for instance, like this one I just talked about, they were interested in that. So myself, I have trained those two guys anyhow. uh, but what we will do is uh, Dan and I will review that risk assessment together, and his name will go on it as well as being the party, and his certification number will be part of that risk assessment.
Gotcha. Okay. Okay. We got another question here. It's talking about the next phase. So what is the next phase of updates to the specification? Will there be new sections, or what are they looking at next?
Well, really, the next ANSI requires that we review it every 5 years, but really it's based on market feedback. If we're hearing that there's a lot of new things coming on the market, we may uh, elect to take on reviewing or putting out a, we could actually put out a technical report with updates to this. Right now, I think the biggest concentration we're going to have is trying to get parts 2 and parts 3 done so that we have a complete document out there.
Okay.
This time, normally the European market, the ISO market, takes the lead on developing standards. And the US now, we're actually actively adopting the international standards so that we have harmonious, and so is Canada, so that we have harmonious standards pretty much all over the world. This time, since there was nothing in the international community, the US actually took the lead in developing one for IMRs or AMRs. And the hope is that the international community will jump on and follow us. And it looks like that's the way we're going.
Okay. Excellent. So where can they get this part 1? I noticed it was looked like it was a report. If we were able to send this out to all these guys who have to jump on here, some of them may or have it, but
Well, they can get it from the ANSI bookstore. They can go on and Google ANSI bookstore. They can find it on there. Or they can go on RIA's website, which is now called A3, uh, because instead of uh, RIA, the name changed mainly because it always did consist of these, but we combined them more. It's robots, it's actually drives, and it's actually vision. All three, they all work together. So they said, why not just combine it into one?
makes sense.
But it doesn't matter if you had the old link to RIA's website, it will still take you there. And you go in the bookstore and you'll find safety documents where you can purchase it.
All right. Well, excellent. Well, hey, I'd like to give a little plug to you as well. Obviously, thank you for doing this. We don't have any more questions that popped up at the moment. Because Mike, you are the co-owner of the Safety Center, which is the Robot Safety Center, which is a cloud-based robot risk assessment software, which is compliant with the R15.06 2012. And I believe you said you are working towards some new improvements and updates as well. I know some of you guys are actually on the call here, actually are already customers of Mike, and so we appreciate you joining this as well. But if anyone else would like to reach out to him, we'll be sending out a thank you for attending after this, as well as links to rewatch this, and Mike's contact information will be a part of that as well. So if there isn't any questions, Mike, I just want to kind of thank you for doing this. I know taking out your time, you've been an asset to us at the RG Group doing our things, and we appreciate you giving back to some of these folks that are on the call today by answering some questions. And so if there isn't any other questions, we'll just kind of wrap it up from here.
Well, hopefully they've all gained some useful information. And as to say, the contact information is there. If they wish, they can email me or call me, and we'll try to answer any more questions they have.
Perfect, perfect, perfect. Again, Mike, thanks for your time. Everybody on the call, thanks for your time. And I hope you have the rest of a great day. Take care.
Bye now.